Hi everyone, hope you're having a great day. Today we are going to learn about equations that sometimes have one solution, which we've learned in the past, no solutions, brand new to us, an infinite number of solutions, which is also new to us. So these notes are going to go into your notebook, and I'll talk about that at the end, how we're going to get it into our notebook. The first thing that I want you to do is I want you to take a look at this first column. And if you notice, this is like a scale. And we have on the left 4 unknowns, or 4 x's. And that is balancing or equaling 2 unknowns plus a box of 6. So when we go ahead and solve this, we are going to isolate the variable, or rather gather the variables, and then isolate them. So the first thing that we need to do is we're going to move the 2x, so the opposite of positive 2x is negative 2x. We're going to subtract 2x from both sides. 2x's cancel out, bring down the 6. 4x minus 2x is going to give us 2x. We're going to go ahead and divide both sides by 2. 2 over 2 leaves us with an x, and 6 over 2 leaves us with 3. So what this means as a visual representation is that one box represents or equals 3. Okay, and we've done equations like this in the past, so this should be quite familiar. If we're going to go over and take a look at the no solution, let me zoom in a little bit. Okay, we have an unknown box, so we have x plus 3, and that is equal to an unknown box plus 5. Okay, and when we go ahead and we try to gather all of our x's to one side and all of our constants to one side, we can subtract an x from both sides. X minus x cancels out, drops down a 5. X over x, ooh, this 2 also cancels out, and we bring down a 3. Now in this problem we have to think about this. 3 equals 5. Does 3 actually equal 5? Can that be? Well, it can't, and therefore there are no real solutions. Okay, we're going to move on to the infinite number of solutions, and if we take a look, we have our unknown box plus a 4, and that is going to equal an unknown box plus a 4. When we go ahead and solve this, we're going to gather all of the variables. So we're going to go ahead and look on the right, subtract x from both sides. X minus x cancels out, drop down the 4. X over x cancels out here again, drop down the 4. So now we want to take a look at this answer. We have 4 equals 4. Well, is that true? Yes, it is true. So therefore, we have infinite solutions, meaning that any number will work in this equation. There isn't just one or none. It's any possible number that you have. Now, as we continue further on, we are going to encounter equations that are a little bit longer. You're going to have to distribute, you're going to have to simplify or combine like terms, and then figure out what's going on. Okay, so what I'd like you to do, we're going to create a pamphlet. We're going to right fold into the line, left fold into the line. And then what I would like you to do is I would like you just to write on the top 1, none, and infinite solutions. Okay, go ahead, put this into your pocket of your notebook. We can glue this in tomorrow. But right now what I want you to do is I want you to take the second page that you have And you are going to, with a partner, you are going to solve all of these problems. There are 3 by 2, 4, 6, 7. So there's 21 problems. Some of them have one solution. You'll get an x equals a number. Some have none, where you'll have only the constants left and they won't be equal. Or you'll have infinite, where you'll have only the constants left and they'll be the exact same number on both sides of the equal sign. And those will be infinite solutions. So what I want you to do is I want you to take out a separate sheet of paper. I want you to solve all of these. It is your choice whether or not you want to cut these out and paste them next to the work, or just copy them over onto a separate sheet of paper. Okay? If you have any questions, I will be here later this afternoon to assist you, and I will be after school. So I hope you guys have a great day, and I will see you later.